Welcome to the first lecture for BIT 4514, Database Technology for Business. In this lecture, we will be talking about how databases fit into the bigger picture of decision support systems, and we will discuss the motivation behind why we create and use database-driven systems, which is due in part to the differences between data and information. Our discussion will also look at some of the issues associated with the traditional file-based approach to managing data, and then talk about the relative advantages that a well-designed database system can provide. The lecture is broken into several individual segments, each of which is around 5 to 8 minutes long. We begin by defining what we mean by decision support system. If you are majoring in BIT and have chosen the DSS option, then you're going to be earning a degree in decision support systems. Suppose that you are talking to someone at a party about what you do, and they ask you to explain what a decision support system is. You should be able to tell them without even having to think about it. Although there are many different definitions of a DSS, the one that we tend to use here in our program is the following. A DSS is a computer-based information system that uses data and models to help a user solve semi-structured or unstructured decision problems. There can, of course, be decision support systems that are entirely paper-based, but those aren't really relevant for the types of complex decisions that we are looking at. It is important that we include both data and models. We need to have numbers to support our decisions, and we have to have models to help us analyze those numbers. It's also very important that the system is helping a user solve problems. The system itself is not solving the problems. This implies that the user, him or herself, is an integral part of the actual system. Finally, decision problems can generally be classified on a continuum from very structured to highly unstructured. A structured problem is one that an algorithm can be written for so that it can be solved automatically without any user input. Balancing a checkbook or solving a linear programming problem are two examples of this. You always do it the same way and you always get the same answer. On the other hand, an unstructured problem is one for which no algorithm can be written. Solving such problems requires human expertise and judgment, such as hiring a new employee or creating a new product. Semi-structured problems typically have both types of characteristics. They have aspects of them that can be automated and other aspects that require human intuition or expertise. These are really the types of problems that a computer-based decision support system, with its combination of computing power and human input, is intended to help solve. This diagram provides a look at how a software developer might view a decision support system if they're actually working at creating one. Based in part on our working definition, there are 5 major components to such a DSS, 4 of which you will almost always find included and 1 of which is optional. As we discussed on the previous slide, the most important component of the system is, in many ways, the user, because it is the user who actually does the problem solving. If we are going to include a human user, we therefore must also have a means by which that user can interact with the system. So we need some sort of user interface, or a means of managing the dialogue between the user and the rest of the system. This is often a graphical user interface, or GUI. The graphical capabilities allow the user to interact with the system in a very flexible manner. Because from our definition of a DSS, the system will incorporate both data and models, we also need to include the functionality to manage those elements as well. A database management system, or DBMS, provides the ability to manage and retrieve data, while a corresponding model-based management system provides the same opportunity to manage different types of models that might be used in the system. In the case of the database management system, the actual data may either be internal to the DSS or it may come from outside the DSS, such as when the system accesses stock market data from some external source as part of its overall functionality. This combination of data and DBMS is the focus of this particular class. The last main component that is sometimes included in a decision support system is the knowledge-based management system, or KBMS. This provides the functionality to automate some aspects of the decision-making process by storing derived if-then rules so that certain types of decisions can actually be made by the system to reduce the cognitive load on the decision-maker. A well-known example of this comes from the Campbell's Soup Company. They had an employee who worked for many years on the production line for their signature tomato soup. Over time, he had developed the ability to dynamically adjust the different production machines on the fly, in order to maintain the consistency of the final product. When he decided to retire, however, there was no one who understood the process well enough to step in and maintain this consistency. The company therefore invested in developing a knowledge base of if-then rules that specified specific actions to take in response to many different hypothetical situations. This greatly simplified the decision-making process required of future employees who worked on that line. As this first definition indicates, a database is a collection of interrelated data organized in such a way that it corresponds to the needs and structure of an organization and can be used by more than one person for more than one application. It's significant to note that this implies that exactly the same data could actually be organized in different ways, depending on who owns it and what it will be used for. So the purpose of a data set can determine the way in which it is stored. A DBMS is then a system whose purpose is to enable storage and retrieval of this data, and to control the database in which that data is stored. This may involve such things as providing secure access to that data, as well as managing conflicts between multiple users who are each trying to change the same portion of the data set. It is important to note that a DBMS is not itself a database. A DBMS is simply a software application or set of applications that is used to manage a database or databases.